Lecture 1, Introduction to Wireshark and Networking. In this lecture, we will cover the following points. Where does a protocol analyzer fit into the OSI model? Wireshark installation tips and tricks. This is in Windows. What is NDIS and how does it affect you capturing on wireless networks? Watch out for switched networks and general tool placement. IP, TCP, UDP, checksum errors, and offloading nodes. This is a very popular topic. A bit about taps. We're going to cover non-aggregating and aggregating taps. Analyzing routed networks, basically when you have a trace file and it goes through a router. I'm going to show you how to filter on a MAC address to either exclude or include the remote network. Keyboard shortcuts. You get a nice list of all the Wireshark keyboard shortcuts without having to go search through the internet. Where to locate the various Wireshark folders, and lastly, how to make it easier to launch Wireshark within Windows. Let's get to work. Before we get into Wireshark, we have to figure out where and why do we use it. So the best way to do that is to look at the OSI model. So here's the OSI model. I've only got 5 layers of the OSI model, not the 7 that you're typically used to seeing. And in this case, the reason why I've done that is because layers 5 and 6 are always pretty hard to visualize and don't relate to things obviously to people. So in this case, we'll start with the physical layer. Physical layer, as I always joke, that if it can electrocute you, blind you, or hang you, it's layer 1. And that's where you've got your electrical signals, your lights for fiber, you've got radio signals for Wi-Fi and that sort of thing. And all of that stuff at layer 1, it's important to understand, you cannot troubleshoot that directly with protocol analyzer. You will indirectly see the problems created by the physical layer, like retransmissions, or you might not see a packet because it's lost, that sort of thing. But the physical layer issues, like noise, you will not see that with a protocol analyzer. And we're going to cover that again in just another slide or two, but I just need to put that out there right now. So if you do have to troubleshoot at layer 1, you're looking at cable testers, or on the radio side of things, spectrum analyzers, or fiber optic analyzers, that sort of thing. So protocol analyzers start at layer 2. Right? So MAC addresses, you got your IP addresses, you got your TCP, UDP addressing, and of course the application stuff up at layer 7. So the protocol analyzer itself can help you layers 2 all the way up. And that's kind of important, again, to keep in mind that the protocol analyzer, in this case Wireshark, will only help you with layers 2 and up. And now, a little note, if you do want to just kind of map this to devices you might see on your network, physical layer is obviously your cabling, right? Or radio if it's wireless. Layer 2 is going to be your layer 2 switch. Switches are layer 2 by nature. It gets a little complicated because some switches have the smarts of layer 3, which is layer 3. So layer 3 is going to be your routing layer. So just because it's built into your switch just means that its switch has a little extra software to do that layer 3 thing, right? But switches by definition are layer 2. That's the MAC layer. Routers are layer 3. Layer 4, we're talking a lot about firewalls, for example, that sort of thing where you can block a port number, right? And then at the application layer, we're talking about things like proxy servers, some sort of application address translation servers, that sort of thing is all the way up at layer 7. Now that we know where Wireshark fits into the OSI model, a better question is why? Why do we even bother? Well, Wireshark can be used for all sorts of things. For example, to determine how your applications behave. This could either be because you're doing an application profile, you want to make sure you know what it's talking to. It could also be a troubleshooting exercise or security, if you're trying to find out why things are talking to certain things that they shouldn't be. To identify application dependencies, right? So there's this whole concept we're going to talk about later about application dependencies. When you run an application and you try to go to a server, well, a whole lot of other things have to happen before you even get there, like DNS lookups or LDAP lookups, that sort of thing, right? For assisting in configuring firewalls, it's a very common thing where you have an application that has to get through the firewall. And guess what? You don't know the behavior, you don't know the protocol, the port number, that sort of thing. And it's very difficult to configure a firewall to let that through. Understanding why your application is slow, that's a big one. So if you don't have a baseline, it's not the end of the world. I'll show you ways around that. But if you do have a trace of your application when it worked well, then you can always compare it to when it doesn't work well. And that's why I always stress that you should do your captures when nobody is complaining, because then guess what? That's called a good baseline right off the bat. So if you can take a capture, which I will show you how to do in this course, then you'll always have something to reference. Don't wait until somebody complains. You should always have a baseline prior to that. To see if critical data is in clear text for security compliance, and you see that, I see that all the time, where an application is sending an account number, a password, a user ID, that sort of thing, over the air if it's wireless or the wire, but over the network in clear text. Clear text means that you can read the data with no effort. Right? We're not talking about trying to hack it or crack it or apply some sort of security key or encryption key. This is just the way it's sent out over the wire. And I'm going to talk a lot about that through this course. Make sure your PC is configured optimally. That's a big one. So all the little things that you learn, you can try on your own computer at home and work and try to see if it makes things work better. In many cases, you know what? It's not going to give you a noticeable improvement in performance, but you'll notice that things are more consistent and they're more stable. You can identify viruses, Trojans, worms, other uninstalled software, and that's another big thing, right? So if you are looking for why your machine is acting strange, or if you know there is some sort of infection on your network, many times Wireshark can help you identify that, and you might be able to zero in on which computers are infected by protocol analysis. You can also monitor networks for unwelcome applications. So if you do have some apps on your network that are slowing things down and you don't quite know what they are or how to slow them or how to stop them, then you might want to capture some packets, figure out a pattern, an IP address, a name, a port number, and then you could stop those applications like peer-to-peer or torrent applications, streaming, that sort of thing, things that are trying to clog up your network. And lastly, we can validate network component configurations. So you can configure a switch, a router, a firewall, a server, a camera, a thermostat, any way you like. But at the end of the day, you should perform a capture to find out how that thing is behaving on your network and ensure that it's behaving the way you think it is. So if the camera's not supposed to use the cloud and you do a capture and it is using the cloud, then you can try to figure out why and how to prevent that. Since this course is concentrating on Wireshark running on Microsoft Windows, we're going to go through a few Windows notes. Number one, always check www.wireshark.org for the latest version. In some cases, I've seen Wireshark's update process not work because of firewalls or policies on your computer. So if you're ever in doubt, please go to wireshark.org and double check the current version. When it comes to installing Wireshark, there's a no GUI option. I'll show you that in another slide. And that will install Wireshark without all the installation props, which is extremely helpful when you try to install Wireshark on a customer's machine and you don't want them to have to go through all the installation screens. The other one is Wireshark will automatically update if everything works, right? So if that does work on your system, then you're good to go. But for whatever reason, if you don't see an update for a year or two or whatever, please check wireshark.org and get the current version. Now when it comes to WinPCAP, it's another piece of software that Wireshark will install. If you do not have it, it will install it. If you have an older version, it will update it. So WinPCAP is a piece of software, it's a driver, and it's required by Wireshark to see or access your network cards. Now one thing about WinPCAP, it's another piece of software on your system. So WinPCAP sits on top of your Microsoft drivers. Now when it comes to WinPCAP, like any piece of software, you probably will not see physical level errors from Wireshark. So if you're trying to capture things like late collisions, that sort of thing, you will not see the physical level error. You will not capture a corrupted packet, so to speak. So just know that going into it, because lots of vendors sell products that have their own drivers with their own cards that allow you to capture physical level errors if that's what you need. The other note is because you have WinPCAP sitting on top of NDIS, you may encounter some performance issues on very busy networks. So again, keep that in mind. Now, with performance, you also have to understand things like USB adapters. I've seen many people use USB Ethernet adapters on their desktop, on their laptops. Please make sure you understand the nature of USB. If you have USB 1, USB 2, that sort of thing. Every single one of those will have different performance parameters. And if you're not familiar with the version of USB on your computer and the version of USB on that adapter, you may drop packets, or worse, you may have inaccurate timestamps. So again, just be careful about that stuff. I always encourage people with USB adapters to use that in a test environment or just playing around, but you don't want to do that on a production system. Down here, we've got a little graphic. We've got our switch, our network. The data comes in to your card. Now it goes through the Microsoft NDIS. Then it goes through WinPCAP, and then from there it goes to the operating system and onto Wireshark. So it's incredibly important to understand this architecture if you plan on obviously building like a couple of Wireshark boxes and just for everyday use. Capturing on a wireless network is always a popular question, and it's for the following points. So by default, you cannot capture wireless beacon or probe frames. Some people call them wireless administration frames, and you just can't capture them by default. Microsoft will strip those out. You'll just end up with data packets with Windows. So just because you can capture with a Wi-Fi adapter doesn't mean you have the entire packet. If you want to capture 802.11 headers or these administrative type frames, you need to either purchase a wireless adapter for that specific purpose. There's one called AirPCAP by Riverbed, or use a different operating system. Some of them by default will support that type of capture with the default adapter you have. You'd really have to do your research and check it out. Wireshark can read most trace files from other wireless packet capture vendors. So even this was not captured with Wireshark, and I opened it in Wireshark, and this is what you're looking for. You're looking for this type of information. This is radio information. You'll see this thing, probe response, and then wireless LAN management frame. So this is not a data packet, right? This is not your ping or your surfing or your IP. This is just what Wi-Fi needs to do in the background to make things work. So it's important that you check your adapter, do a quick capture on your Wi-Fi, see if you have this type of header, this 802.11 type stuff, and if you do, you're in good shape. If you don't worry about it. It's just the way it is, and that's the default way that Microsoft behaves. Okay, the next few slides are going to cover installing Wireshark on Windows, and these are installation command line options. So when you run the setup file with no options, or you just simply double click on the executable in whatever folder you've downloaded Wireshark to, you get the standard installer and it walks you through the install, which is fine. But here's some command line options you may want to be familiar with. There's a slash capital S, uppercase S, and that runs the installer or uninstaller silently with default values, which is really helpful to know. Now with these default values, you'll end up with a desktop icon and a quick launch icon. If you're not familiar with those terms, it just means that you end up with an icon on your desktop and literally an icon along the bottom part of your status bar near the start button. And if you don't want that, then you can also specify options as well. So this is a very powerful little tool to have under your belt when you want to install Wireshark on somebody's machine and you don't want them to have to go through the installation process and click through every single dialog box. Now on the next slide, you're probably wondering, how do you check the installation progress? Well, there's a few ways to do that. You can check it in your task manager and you'll see the installation executable running. Okay, that's one easy way to do it. The next way is just pay attention to your status bar or your quick launch bar, and as soon as you see that Wireshark icon appear, then you're done. And that's a really easy way to find out when you're done your installation. Alright, this slide could go on for hours, so let's try to summarize this, and I'm sure you'll see where I'm going. On switch networks, you've really got to worry about your tool placement. Where are you putting your tools, and what are you going to see, and what are you not going to see? For example, between these two boxes, these two switches, there's a trunk port, an uplink port, that sort of thing. If you are using packets that exceed your typical Ethernet packet size of 1,518 bytes, like jumbo frame sizes, you have to make sure that whatever analyzer you have can actually capture those packets. If not, it'll be misreported as an error. You don't want that. You want to make sure you can actually see the full size packet. Down here we've got a monitor or good old span port. Some vendors call it conversationally steered, that sort of thing. All that means is that you're going to get a copy of this packet from another port, the originating port. You're getting a copy. So just be careful, because monitor ports do not forward packets with physical level errors. So if you're watching, a good example, a fiber connection, and there's dirt on the fiber, or it's crimped, or there's something wrong where you're getting errors, and you have a monitor port or a span port to a copper port, for example, you're never going to see the errors, right? So you just have to make sure you understand what you can and cannot see. The best way to deal with that is just go with SNMP or log into the switch and look at the port statistics, that sort of thing. Down here, we've got a port that we want to monitor, and this time we're going to use a tap. We're going to talk about taps in just a moment. And taps allow you to see that traffic. Make sure again that if you want to be able to see physical level errors, that your analyzer allows you to see that. Down here we've got a good old workstation, and it's running at 100 meg, and we want to see everything it's doing. So we put a hub in here. A hub is like a cheap tap, if you will, because people still have a lot of hubs laying around. Just make sure everything's configured for half duplex if you decide to do this, and then any port you connect to on that hub with the same speed as that client, in this case 100 meg, you will capture all the packets. So that's a really great way of capturing packets when you want to see the nature of the traffic. An application baseline and performance is not an issue. Just be careful, because not all hubs are hubs. They say they're hubs, but they're not. They're switches. So if you ever plug into a port on a hub, the same speed as the actual guy you're trying to monitor, and you don't see anything but broadcasts, chances are that's not a hub. It's a switch. Down here we also have another Wireshark analyzer, and this time we're watching a 100 meg full duplex connection. I've got an old NT server here as a diagram. Same thing. Make sure that if you do want to see physical level errors, that you can capture that with your laptop. And more importantly, we're going to talk about the differences between different types of taps. Now we have to talk about TCP, IP, and UDP task offloading with NDIS 5. So basically it's your driver. It's your network card driver that Microsoft has a specification for. And offloading is real simple. When you send data over the wire, you have to calculate something called a checksum. And the keyword there is calculate. So calculations used to always be done in software, in the driver. Well, in the last, I don't know, I'm going to say almost 10 years now, if not more, you have the hardware in your card to do that, hardware. So now instead of software, you're going to use hardware to do that math, which means you get a performance gain. Now, if you go surfing around the internet and Googling around, you're going to find all sorts of reports, anywhere from 10% to 100% performance gain by using checksum offloading. And the one that I found the most realistic was one Microsoft did, and it said that you're going to get about a 30% performance gain in your CPU utilization. It doesn't necessarily mean that you're going to get 30% more traffic through it, but that's what it's all about. Now, checksum offloading is also a big thing for people who have IPsec and VPN equipment. You'll notice that it says that the offloading is done and the math is done on the card. So in this case, the reason why this is really important to understand is because if you have checksum offloading, that means the math is done in the card, which means Wireshark is not going to see a correct CRC, right? So I want to show you what that looks like. So all that means is that when you send data, let me show you, you'll see something that says TCP checksum incorrect or IP checksum incorrect, whatever. And you might think, oh, I've corrupted packets. That's not the case. So here's how you find out if that's true or not. The easiest thing to do is look at your traffic. If that was a checksum error, if that was true and that packet was corrupted, then it would have never been accepted at the other end. It would have even gotten there. So checksum equals corrupted packet, means drop packet, means it never got there, which means you would have to resend. So you would see retransmissions if that was true. Now with UDP, there is no retransmission, so that's a different animal altogether. But with TCP, you would see retransmissions. Now I don't see any retransmissions here, so it's not true. So we have to find out how we can manage this. In some cases, you might not even see this, so don't worry about it. But if you do see this, don't jump to the conclusion that you have a problem on your network. So what you do is, if you go to your adapter, in my case mine's a gigabit Ethernet adapter, this is a Broadcom, and you go to the advanced tab, you'll see it says offloading right here, and it says enabled. So offloading comes in basically two settings. You've got your transmit or send, and you've got your receive. The reason why that's important is because if you do want to have that checksum notification on in Wireshark, then the best thing for you to do is disable your checksum transmit. Then the math will be done back in the software, which means Wireshark will see the checksum, and all of that goes away. The other thing you can do is simply go into your preferences in Wireshark and disable the checksum algorithm, or the checksum message, or the checksum error message, however you want to hear that. And the reason why that's a better way to do it is because, as I said earlier, if that packet was really corrupted, it would have never gotten there to start with, and you'd see a lot of retransmissions. So to me, the better solution is to go into Wireshark and just disable that. But if you did want to do it from your card, well, then that's where you do it. Just check your card settings. Not all cards allow you to change that. Now, if you take a look at the flow of data, you'll see as the packet goes through, in this case, HTTP, TCP, IP, and then the MAC, and then the physical layer, and off it goes. So you would see Wireshark complaining in this case about TCP no CRC, IP no CRC, that sort of thing, and you'd see a lot of errors. The other key is if you ever see errors when you only transmit, not when you receive packets, that's also a good telltale sign that checksum offloading is at play. And Wireshark will even say that to you sometime. It'll say checksum offloading or offloading enabled with a question mark, that sort of thing. And he's trying to give you a hint that maybe this isn't a problem. Maybe this is just a setting on your card. On the way back, everything's going to look fine. So look out for that, because I get a lot of emails and messages about that checksum type issue, and it may not be an issue at all. All right, here we go. We've got a 1 gig full duplex link, and we're going to talk about taps. And the first one we're going to talk about is a non-aggregating tap. You might not see them as often anymore, or you may have one in a closet, or you may see one online for sale, and I want you to understand the terminology. In this case, we've got our Wireshark capture tool, our laptop, and for this to work, you actually need 2 Ethernet interfaces on your laptop. This is another reason why people consider USB Ethernet adapters on their laptop, because you might just have one Ethernet port on your laptop, for example. So in this case, it's getting the transmit data from this switch, the transmit data from this server, and it puts them on separate physical ports, which means I need 2 copies of Wireshark running on this machine to capture 2 streams of data, and then you merge the traffic together. Now, why would you do this? Sounds like a lot of work. Well, non-aggregating taps, some of the good things about it, the pluses. One, it doesn't even need power. These non-aggregating taps are totally passive. The other nice thing about non-aggregating taps, there's no real processor software. It's really, really simple little box, which means it's also very inexpensive, and it's super small. It's like smaller than a pack of cards. Now, you get an aggregating tap. That means it takes 2 transmit streams and it puts it together for you. So now your Wireshark or your tool of choice only needs 1 Ethernet adapter, and it puts everything together for you. Now, when this first came out, there was issues with buffering and packet timings, all sorts of weird little things. But again, over the last, I'm going to go on a limb, the last 10 year plus, this has all been resolved. Any reputable dealer or manufacturer who carries taps and has aggregating taps, it's going to be just fine. Just be careful, because the taps need power. There's going to be some kind of software interface in some of them. And the best ones that I've seen out there have little dip switches on the back. So no cables or consoles or serials, none of that nonsense to worry about. Flip a switch on the back and off you go to the races. So that's all you need to know about taps for now. Okay, in this slide, this is more of a tip or a trick, and it has to do with capturing packets and then trying to analyze them later. In this case, we've got all these devices down here. They could all be from different VLANs, obviously different IP addresses. They have different MAC addresses, going through this switch, going through this router, and off to the internet. And you might want to just capture just the traffic that goes to the internet from this connection, and you don't want to include any of the local traffic, or the inverse. You want to capture just the local stuff and ignore the internet. And what's the easiest way to do that? Well, if you do have this capture, and you can just simply look at the capture, figure out the MAC address of the router, unless you've got it documented, which is even better, and then you basically just look and filter. Do something called a display filter. I'm going to show you how to do that. You can do a display filter for just the router's MAC address, and that'll give you just the remote traffic. Or you can say not the router's MAC address, and then that will give you just local stuff. So that's just a quick trick for you to keep in your pocket for later on. Alright, slide's another tip or trick on Wireshark, and this one has to do with the About screen. So if you go to the menu bar and you go to Help, and then you go to About, you will see the typical About information with the version, all that good stuff. But the key here is to use the Folders tab, and that shows you where a lot of your files are being stored. If it's not familiar to you, don't worry about it. We'll be covering a lot of this stuff throughout the course. And you'll see things like display filters, defilters, and you'll see where they are. And why is that important? Because as you get more comfortable with Wireshark, you might want to just edit the files yourself. They're just text files, and that's where they're all hidden. Now the other good one is the shortcuts. So the keyboard has a bunch of shortcuts, and we're going to learn some of them as we go through this course. And this is a list of all the shortcuts. So for example, if I click on the keyboard shortcuts tab, you'll see a whole bunch of stuff here. So one of the ones we're going to be using, for example, is Control K, which is your capture options. Another one we're going to be doing is finding a packet and the next packet, and you'll see them right there. So this is a really good reference for your shortcut keys, and as you get more comfortable with Wireshark, you'll be referring to this less and you'll be using the tool a little bit more efficiently.